Morning. Right, so I'm just going to go through this question from yesterday and then we'll have a look at max and min problems, which we kind of did before the mocks, but I'll just do another little round of them. Okay, so we have a function. The function is called f. So you can see here it's f of x. This or tells us about the x values or the domain. So the x values here are any real number. And this here tells us about the y values or the outputs, or the codomain or the range. Basically, there's no restrictions here. We can sub in any x value and we can get any y value as an answer. So find the coordinates of the local maximum point and the local minimum point on the curve of f of x. Okay, so as soon as you're asked for local max, local min, you're going to go through the process where you find do I dx, then you let do I dx equal 0, solve, etc. Okay, so you have a choice here really. You can leave it as it is and treat it like a product rule. So this would be a chain rule. So we bring the 2 down, leave the bracket as it is, reduce the power by 1, and then multiply the bracket, which just becomes 2x plus 2. And then this side is just minus 1. And then to get f dash x, it is u dv dx plus v du dx. I mean, to let this equal 0 and solve, you're going to have to expand anyway, so I don't think you're going to avoid expansion. So this is x plus 1 by minus 1. And then if I expand this, I get 4x plus 4 minus 2x squared minus 2x. And this becomes x squared plus x plus 1 times minus 1. Can I tidy this up? I can. Just bring these two together. So it's 2x plus 4 minus 2x squared. This one is x squared plus 2x plus 1 times minus 1 plus 2x plus 4 minus 2x squared. And that gives us minus x squared minus 2x minus 1 plus 2x plus 4 minus 2x squared. So then we can tidy up. Minus 3x squared. Do they cancel? And plus 3. All right, the alternative, as I was saying, was, I don't know which is easier, but to do the expansion at the start. So f of x is x plus 1 squared times 2 minus x. So x plus 1 by x plus 1 by 2 minus x. X squared plus x plus 1 by 2 minus x. X squared plus 2x plus 1 by 2 minus x. 2x squared minus x cubed plus 4x minus 2x squared plus 2x minus x. Okay, so that gives me f of x is minus x cubed, 2x squared minus 2x squared is gone. This is plus 6x and then minus x. And then if we do f dash x, we get minus 3x squared. Oh, what did I just do there? Sorry, that's wrong. Oh, I've definitely done something wrong. Hang on. 2x squared minus x cubed is right. That by that is 4x. That's right. That by that is minus 2x squared. This one shouldn't have an x on it. That comes from just 1 by 2 and then 1 by minus x. Okay, so let me fix this then. Just a minus x there. Okay, so minus x cubed is fine. 2x squared minus 2x squared does cancel. 4x minus x is 3x, and then I have my plus 2. Okay, so minus 3x squared is still right, plus 3, and then the 2 is gone. So hopefully, oh yeah, so either way, they're the same. Yeah, so much of a muchness. Anyway, so you get your f dash x, you let it equal 0, so minus 3x squared plus 3 equals 0. Take out minus 3, leaves us with x squared minus 1. The bit in the bracket is the difference of two squares, so x minus 1, x plus 1. So we can divide across by minus 3, which will get rid of that. And then we just have x minus 1 equals 0, x plus 1 equals 0, so x equals 1 and x equals minus 1. Now, the question is looking for the coordinates, which means I'm going to need y values. So we're going to need to sub back in. So f of x is y, and that is x plus 1 squared times 2 minus x. So when x is 1, it's 1 plus 1 squared times 2 minus 1. So that's 4 by 1 is 4. So that's 1, 4. And x equals minus 1 is minus 1 plus 1 squared, 2 minus 1. Minus, that's 0. 0 squared is just 0, and it doesn't really matter, but that's 3. We get 0, so that's minus 1, 0. So then our verification, we need to do the second derivative. So minus 6x, and x equals 1 is minus 6 times 1, which is minus 6. Minus 6 is negative, which means it's the max. And then x equals minus 1. Minus 6 times minus 1 is 6. 6 is positive, which means it's the min. So this is the max, and this is the minimum. Okay, so that's part 1. Find the coordinates of the points where the curve intersects the x and y axis. Okay, so when it intersects the x axis, we let y equal 0. So that's going to be x plus 1 squared times 2 minus x equals 0. Now, I've already expanded this somewhere. Well, actually, maybe I don't. Maybe I shouldn't expand it. If I do it like this, x plus 1, and 2 minus x equals 0. And then I can just go x plus 1 equals 0, x plus 1 equals 0, and 2 minus x equals 0. So just treat it like, you know, the end of a quadratic. So that gives me x equals minus 1, x equals minus 1, and this is 2 equals x. So we have a repeated root at x equal to minus 1, and then we have a root at x equal to 2. So that's where it's going to cross or intersect the x-axis, and then intersect the y-axis. We let x equal 0. It should be a lot easier. So y equals 0 plus 1 squared times 2 minus 0. So that is 0 plus 1 is 1 squared. 2 minus 0 is 2. So 1 times 2 is 2. I never wrote the points here, that's annoying. So this is minus 1, 0. This is 2, 0. And this is 0, 2. There they are. Find the coordinates of the point of inflection. Right, so I never actually went through this yesterday. So when I got off the thing, I realized I never did. But I put all of kind of the outcomes here. Okay, so this is what we know about stationary points, points of inflection and saddle points. So this whole first part here is all to do with max and min turning points or stationary points. If you're doing a point of inflection, this is where we are. So we use like this outcome here to help us find a point of inflection. And then if it's a horizontal point of inflection, it's this here. So I talked about all that in the video yesterday. I just kind of never came back to the overview. So there is an overview, which is handy, I think. Right. So we're going to find the coordinates of the point of inflection. So to find the point of inflection, we are going to let the second derivative equal 0. Now I did the second derivative. Second derivative is over here. So minus 6x. Okay, and if I sub that back in to y, I'm going to get 0, 2. So the point of inflection is the same as the y-intercept, according to my maths. Right, okay, so draw a rough sketch. Go down here. Okay, so I've got 2s, I've got a 4. All right, so we go 4. Just trying to give myself an idea of the the size of the graph. So 1, 2, 3, 4. Minus 1, minus 2, minus 3. Minus 4. That's really annoying. Why didn't I just go a bit further? Sorry, I'm just going to do it again. I don't know why I'm making it so hard. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. Just count. So 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4, minus 1, minus 2, oh, minus 3, minus 4. Okay, so we figured out that the maximum point is 1, 4. So that's there, it's the max point. Minimum is minus 1, 0, so that's here. Okay, we found out that minus 1, 0 is a repeated root, so I don't know if you remember what happens there, but I'll show you now. 2, 0 is the other root, so it's going to cross there, and 0, 2 then is the alright, so essentially it is going to come, let me just make it a bit smaller, it's going to come from up here. Minus 1 is a repeated root, which means it just touches the axis and goes back up again. Then it goes through the y-intercept, which is also the point of inflection, up to your maximum turning point, back down, through your other regular route, and there's your cubic graph. And that looks about right. Hence write down the range of values for which the graph is increasing. So the graph, part 5, the graph is increasing here. So basically between, so from the min to the max turning points. Yeah? So minus 1, less than x, less than 1, because it was 1 and minus 1 that were our two turning points. Yeah. Okay, hopefully that's all right. So as you can see, there's loads of questions there. Feel free to give a few more a go. Max and min problems, like I said, we did talk about these. It's just where they bring that concept of finding maximum minimums, putting them into the context of a problem, and generally speaking, you don't have the formula to start with, although that's not always the case, just sometimes. So I'm going to do this one just to kind of reiterate, and then I think that just leaves us with rates of change for tomorrow. Okay, so from a 30 centimetre by 30 centimetre sheet of cardboard, square corners are cut out so that the sides are folded up to make a box. What dimensions will yield a maximum volume? So as soon as we see maximum, we know we're going to find the derivative, let it equal 0 and solve. Thing is, here we don't have a formula. So we actually have to find the formula. Okay, we're looking for max volume, which means the formula we're looking for is the volume of the box. To get volume, it's length by width by height. So the length of the box, when it's folded, is going to be that bit there that I've just coloured in. Okay, and the length of that is 30 minus x, so it's 30 minus 2x. The width of the box, when it's folded up, is going to be this. And again, that is 30 minus x minus x. So 30 minus 2x for the width. And then the height, so when you fold all those little bits up, it's going to stand at a height of x. Okay, so 30 minus 2x, and this becomes 30x minus 2x squared. And then expand this out, is 900x minus 60x squared minus, is that 60x squared again? And then plus 4x cubed. So 30, am I right about that? So 30 by 30x is 900x. 30 by minus 2x squared is minus 60x squared. That by that is minus 60x squared again, and that by that is plus, yeah, that's fine. Okay, so I've got 4x cubed minus 120x squared plus 900x for my volume. So then if I want to find max volume, I have to differentiate. So it's dv dx, as in I am differentiating y with respect to x. Okay? Sorry, I said y and I circled v. I'm differentiating v with respect to x. So that is 12x squared minus 240x plus 900. Let it equal 0. So 12x squared minus 240x plus 900 equals 0. And we're going to solve. I'm wondering... It does. Sorry, I think all of these divide by 12, which is a dead handy. So x squared minus 20x plus 75 equals 0. So you can minus b or guide. The guide is 75. 15. Yeah, 15 times 5. I need minus, so they both need to be minus. So that is x squared minus, I'll put the 5 here, I'll put the 15 here, plus 75. Pair off. So I get x times x minus 5, and I get minus 15, and that gives me x minus 5. So then I have x minus 5, x minus 15. Oh, I just wrote the same thing twice. So I have x equals 5, x equals 15. Okay. So, what dimensions will yield a max? Okay, so I need to know which one is max. So I'm going to do the second derivative. So d squared v dx squared is 24x minus 240. X equals 5. I have 24 times 5 minus 240. So 24 times 5 minus 240 is minus 120. So that would lead me to believe that that's the max. Let's try 15. So 24 times 15 minus 240. Yeah. Is 120. 120 is positive, so that's the minimum. So this value of x will give me a max volume. Now it doesn't want the value of x, it actually wants the dimensions. So the length is 30 minus 2x, which is 30 minus 2 times 5. 30 minus 10, so that's 20 centimeters. The width is, it's all the same, so the width is going to be 20 centimeters. And then the height is just going to be x, so the height's going to be 5 centimeters. And then the second part is find that volume. So, now, I don't know why you'd bother, but you could sub this in here, and you should get the same answer as if you just literally calculate the volume. So the volume is 20 by 20 by 5. So that's 2,000 centimeters cubed. Out of curiosity, I'm going to do it because I want to. So 4 times 5 cubed minus 120 times 5 squared plus 900 times 5. So 4 bracket 5 cubed minus 120 bracket 5 squared plus 900 bracket 5 is 2000. All right. So that's just an example of a maximum problem. Because it's a problem, it's one of those situations where I can't do all of the examples. Like, you know what you're doing. It's just about applying it to a particular example. Okay, so obviously pause the video where you need to make sure you understand the homework. I will be back tomorrow to do rates change. So if you have any questions, just highlight them and kind of save them. I'm going to give you a couple of max and mins from the massive list down here. And as I said, that leaves us with rates of change. All right, I will see you guys tomorrow.